Elimination method, that's where you can actually add the two equations together, make sure that your x's are on top of each other and your y's are on top of each other, and that's pretty much the only thing you need to do. And then literally, like I said, we just add them up. 6x plus negative 6x is nothing, that cancels. And negative 4y plus 3y is negative 1y. And then negative 16 plus 18 is 2. We can now go solve for the y. You treat it just like any other equation at that point. And y would equal negative 2. Guess what? That's half your answer. And so now what you can do to get the second uh, part of your answer, your x value that's missing, you come back in and you steal one of these two equations. It doesn't matter which one, you choose the easiest one. So let's take that one. 6x minus 4y equals negative 16. Remember that this is a y value, it's negative 2. So I'm going to take that and slide it in here. And negative 4 times negative 2 is positive 8. And now we can solve for the x. So after you're done with the two-step equation, you find out very quickly that x is negative 4. So what's our answer going to be? Negative 4, negative 2. That's how the elimination method works. Now there are some different wrinkles that we need to discuss, and we'll take a look at those examples. Now, initially I said, hey, all that we need to do is go through and add the equations together, because we call the elimination method when one of your variables are eliminated and their x's were eliminated and we could go solve for the y. That's not always going to happen though. Negative 4x plus 8x is 4x. Negative 5y plus negative 15y is negative 20y. And this would be negative 40. Here's the problem. I didn't eliminate x's. I didn't eliminate y's. I can't go and solve. So basically I've just wasted my time. What you can do though is that you can multiply any of the equations by any number that you want to change them. Now, if I can make this negative 4x into like a negative 8x, well, negative 8x plus 8x is nothing, and that would cancel. So what I want to do is I want to multiply this negative 4x by some number to change it to negative 8x. So I'm going to multiply it by positive 2. 2 times negative 4 is negative 8. And there's the x, so we'll just tag that right there. We distribute. And then 2 times, we got to do the entire equation. If we have to do it, that's the only trick. 2 times negative 5 is negative 10. That's got a y, so we'll put a y right there. Equal sign comes down. And now 2 times negative 10 is negative 20. So we've taken this first equation and we've multiplied it by 2 to make this equation right here. And now we can add our equations together. 8x plus negative 8x is nothing. This would be negative 25y, and this would be negative 50. And we can solve for y. So we've got our y value of positive 2. Now we can come in and still one of the equations. So that way we can find out what x is. Well, our y is 2, so this y needs to be positive 2, and it's multiplying it. Now, this is not 0x, so we still need to go through and divide it, both sides by negative 4, and so x would equal 0. Almost done. If we take a look at a third option down here, a lot of times you could say, well, okay, if I add them up like this, nothing canceled. And so I need to change one of the equations. Well, then you run into this scenario. Can you times this 4 by something to make it negative 3? Nope. Can I make this 3 into like a negative 4x? Not easily. Same thing is going on with the y's here. So instead of changing one equation, we need to go through and change both equations. The best thing I can tell you is that take a look at both your x's or both your y's, figure out which ones are the smaller numbers, and then see this 3? I want you to take that 3 and I want you to carry it up to the top and multiply the whole first equation by it. And see this 4, I want you to take it down to the bottom, multiply the entire equation by it. And then you need to figure out how your signs are going to go. This would be 12x and that would be 12x. I need one of them to be a negative. So let's just slide a negative sign right there. And I'll tell you what, let's actually make the top one into blue so that way we can kind of color code here. We go through and we multiply the entire equation by 3. So we get 12x minus 21y equals negative 66. Then we come through and we do the whole bottom equation by negative 4. And watch how this sets it up. Negative 4 times positive 3x is negative 12x. And that's why I made that a negative 4. So I'd get the negative 12x. And then negative 4 times negative 10 is plus 40y. And then negative 4 times negative 26, we would get 104. And now we can go through and add. Our x's would cancel. We would get 19y. And over here we would get positive 38. And we can solve for the y now. So our answer, again, we got the y first, is a 2. And we still need our x value. So we go back to one of the original equations. And wherever we see y, we plug in the 2. And of course, that's going to be negative 14. So we can add it. And we find out that x is negative 2. Now, before I go through and show you the very last part of this lesson, let's recap. Sometimes you can just add the equations together and it automatically cancels out one of the terms. So you're left with one and you can solve it. Then you plug this back into the equation, like what we did over here, to solve for the other variable. Okay, that's how that one works. Other times you're going to need to change one equation. And the way you do that is you pick a number to multiply the entire equation by and use distribution to make that new equation, and then you can add it up. You get one variable left over and you solve for it, plug it back into one of the equations to get the other variable. Very similar to the first one, but again, you're going to have to do a little bit of multiplication. What do you multiply it by? Whatever it takes to make this into an equation that when you add it, one of your variables goes away. And then the third example is that's where you need to change both the equations, and you're going to have to multiply both of the equations. Why? Because you couldn't easily just change one, so you're going to have to change both. But the idea is that you put them together so you can add the equations together, and it would cancel out at least one of the equations. I don't really care if you cancel out the x's or if you cancel out the y's. You just choose whatever's easiest. But now we come to the very last part. Um, for the elimination method, you need to know how to find out about no solutions and infinite solutions. And so what I've done is I've set up this scenario right here. You've got this set up and you're ready to add the two equations together. Your x's would cancel, and then suddenly you see that your y's would cancel at the same time. Well, that means that there's a 0 left on the left side of the equation. And what's negative 20 plus 20? 0. So when you're left over with an equation where 0 equals 0 and there's no variables left over, quite frankly, you know that that is an infinite solution. Over here, when you go to set it up here, you don't know what's going to happen yet, but you'll notice that your x's cancel and also your y's cancel. So you've got 0 left over on the left side. But this time, you get 7 plus 3 is 10. Well, this is a fake statement. This is an untrue statement. It's false. So you would say, sorry, there's no solution. So that's the elimination method. Takes a little bit of practice, but most people like this one better than substitution and graphing. If you've got questions, please let me know.